Our exceptional speaker of the night, Peter Zaitsev, who is welcome to come forward. Thanks. Peter is, for those who are completely missing the emails that we just signed up to, CEO of Percona. Now, for those who don't know Percona, it's kind of hard to believe you don't know Percona, but it is pretty much the MySQL company in the same way like Zend is the PHP company and Enterprise DB is the Postgres company. Percona is like worldwide known as the official MySQL support company. Peter himself is a very exceptional guy. By show of hands here, who knows who Monty Guadinius is? Okay, most but not all. Monty is the guy who created MySQL. Monty personally recruited him to MySQL before he started Percona. So we're talking like superstars, MySQL super guy here. So without further ado, Peter, scaling like rock stars or scaling for monster traffic?
Yeah, whatever. You asked me to have some cheesy name, so you guys like cheesy, right?
Yeah, cheese is good. Pizza, cheese, yeah, sure.
Okay, cool.
Without further ado, Peter's like,
so we'll speak about the scaling. I will come up with some smart things, but I was told not to try to do that. Why? Okay, so we'll start, and you know what? My sales guys always tell me I have to start with saying something good about Percona, and I'm very bad at that. But happily, I have Tom with me. He will stop drinking cola now and say some fancy words about Percona. I have no slides for you, Tom.
Okay, I'm Tom Basil. I'm the Chief Operating Officer for Percona. Peter and I go back about 10 years. We were both early hires at Monty Guadinius, who was the original MySQL team. I was the Director of Support for MySQL. And I still remember a very excited Monty one day when he told me that, hey, I recruited Peter. You're going to love this guy. And I think the first time we met was in St. Petersburg, Russia, about 10 years ago. So I was Peter's boss for 5 years before he launched to go out and Percona. And Percona started with Peter and another member of the MySQL support team. Oh, thank you. Vadim Tashenko, who's the CTO of Percona now. And Peter and Vadim have successfully bootstrapped Percona from a 2-person startup to approaching 45 people full-time now with no venture capital. It's as totally self-funded as they go on. What Percona does, Peter pioneered the idea of on-demand emergency help for MySQL. The original business model for the MySQL company was annual support contracts. Peter pioneered the idea of, hey, call us up. You don't need a support contract. If you're in trouble, just give us a credit card. We'll go to work for you in 20 minutes time frame. And that has proved to be a pretty popular model. There's a lot of people who are going that way now. That has expanded to a fork of InnoDB, starting about 2 years ago, now known as ExtraDB, which then led to an enhanced version of MySQL, which is now called the Percona Server, with ExtraDB as its official name, or just the Percona Server, which has a fairly narrowly defined set of patches for performance optimization and for better instrumentation. And that's also emerged into extra backup pool utility that is the first and only open source backup tool for MySQL. And now we're doing a lot of custom development work. We do annual support contracts now. We do, people who have stalled bug fixes come to us. They can't get done. We have an engineering team. We're the only independent MySQL provider that has our own engineering team. And it includes a fair number of people who came out of MySQL originally. Peter's been a very generous boss. Now that I used to be his boss, now the tables are turned. But it's been a great experience to see we were up here meeting with some prospective clients, and it's really neat to see the open doors that Percona has had with since Oracle acquired things, a lot of people have reevaluated their loyalties and have been looking at third-party alternatives, and Percona has really been well positioned there. So, Peter, is there anything I left out? Key items there.
You missed a training.
Training.
Oh, training, yes. Percona also does training. And we have somebody who had been one of the senior people in training in MySQL is now with Percona. So we have courses published through our website. And so we are an alternative to Ronald, who we respect.
We will work together.
We work closely together. We've known each other a long time, really respect each other. We've tried to hire Ronald many times.
You keep trying.
Okay. but that's a little bit of Percona. Be glad to answer any questions if you have them now or talk to me.
Well, we'll have a QA session after the presentation.
Okay. You're going to take over all my talk with all this like marketing crap.
Give me the mandate.
Okay. So we are going to talk about scaling, and I guess the first good question I would ask is how large do you want and need to be in terms of your scale? And I especially put these questions out there because what we see a lot is people read always like fun stuff, about Google, Yahoo, Facebook, whatever, some very big installations, and they see, okay, how do we do the same, right? And the question is that their application may not really need that, right? And that can be like as funny as you would come and take a look at the application and would say, okay, what is your more ambitious growth plans for the next 10 years? And you would see what even if those all come through, then it can be perfectly run on a very simple infrastructure, with MySQL and with some thing for HA. So that is what would be my first and big disclaimer, right? You have to really understand where you are and wherever you need to scale large in terms of making your architecture more complicated in some ways I'm going to speak about, or you don't really need it. And all those more complicated architectures, they do cost more. They often would slow down the development. They also do slow down things, testing and operations and this kind of stuff. So, about simple approach, right? I would say what we see a rather large number of companies which are successful, right, embracing actually operator approach and say, hey, you know what, we just want to have MySQL, right, we just want to scale up. And that may be possible with modern hardware. The 37 Signals, this is the guys who wrote Ruby on Rails, right, and built a lot of very popular apps around that for hundreds, thousands of users, right? They kind of despise sharding, to put it this way, right? They would rather prefer to say, hey, I want to have my simple database, right? I don't really want to do a sharding because it's complicated. I don't really even want to do a replication for purpose of growing, because that means for purpose of scaling, because that means I will always have to think. I will always have to think wherever it's okay for me to read the stale data in this case. And brain cycles are expensive. It's much easier to just buy a bigger box, right? Up to a certain level, and you can get a lot, right? These days. In our case, I've been working with some pretty large enterprise companies which use Drupal-based internet, which is they have 200,000 employees, and most of them are using that daily basis. Frankly, it's actually the mandatory start page in their browser, right? So that each time they start, it always goes to that internet site, even if they choose to spend the whole day on Facebook, right? So it's pretty popular, and a single MySQL instance is handled pretty well, which has been very loaded to less than 25%, right? And I just want to understand those numbers and what you can be relatively large scale systems right now, even without a complexity. I mean, 200,000, that's probably, top, I don't know, fraction of percent of companies right out there that, building internal systems. So, what about the hardware these days, right? And I like to see what an affordable server is, right? Then what I mean by affordable is it doesn't mean that it really costs very much, but that is very little. But that is when price performance of a server sort of remains constant, right? You can pretty much increase number of memory or cores, right, with pretty fixed costs per one, right? Up to probably 24, even probably more with the cores these days, right? You can get 56 gigs of RAM in a lot of systems. Like we are playing with like Cisco box, which allows you to get to almost 400 gigs of pretty affordable memory. And that is a lot of memory. Now, flash storage, that is another like life-changing factor. You can get like hundreds of thousands of random IOs, which is again a lot different. And all this stuff really allows you to deal with 100,000 plus simple, more or less, queries a second on single hardware. Now, of course, something to mention here, and what was always often the MySQL limiting factor is MySQL ability to use large-scale hardware effectively. And I think there is a lot of work has been done recently in a new plugin in the recently released MySQL 5.5. We've done a lot in Performance Server as well. Right, so right now MySQL scales on those, like I would say, it's high-end commodity hardware a lot better than it was. With some limitations, which I will be also spoken about. Now, what is important about hardware, wherever you choose shard or not to shard, it's important to choose hardware right for your needs. In a lot of cases, I would come into something that people say, oh no, MySQL just doesn't work for us. It's way too bad. And then you would see what a lot of that stuff comes from really poorly chosen hardware. People thinking, you know what, we need 10x from what they have right now. And that looks like unattainable, right? It looks like, wow, you know what, I'm having a pretty decent server. So it would be unrealistic to expect from me I can just buy different hardware and get 10x more. Well, it's possible in many cases, right? One example, I would have a customer which was using 16 gig servers, right? I don't know why, but that was like a large company which had all the policy. Hey, you know what? Memory is expensive. I don't know, it's probably from 10 years ago, whatever. So we won't allow you to buy the box with more than 16 gigs of memory. You can buy a lot of spindles, right? You can buy 20 spindles per box or more if you want to, right? Well, guess what? If your database status, the working status, for example, is 64 gigs, right? Database in total is maybe 100 gigs, then you can get 10, 20, 50 times better performance by just getting a bit more memory in this situation, right? Because memory is so much faster than disk, I guess, we all know. And memory is so much faster than flash storage even, right? That is like, I think, some of the misconceptions about flash storage kind of sort of a replacement for memory. Like I/O doesn't matter, it still does. Now another case would be again using a lot of storage, and I mentioned that because if you take a look at some people thinking, okay, flash is expensive, so why don't we buy a lot of small 2.5, let's say, inch, like 15K APM hard drives, so it gets a lot of signals, and those guys are expensive, right? In this case, you can, the shelf of that hard drives could be cost about the same as let's say, Fusion IO card, right, or as a set of some solid state drives. But again, for whatever enterprise hardware policies or maybe misunderstanding, you can get those buying decision made, then it is pretty bad performance and scalability potential. And I can say for myself, it's I don't know. I can say I really feel really bad when people are wasting money, right? And it hurts me so bad when I come to something and say, oh, you know what, you just have to install hardware. We just spent those $500,000 and bought the hardware. I said, okay, guys, you know what, you should have told me before, not after. Because you should have, bought half as many servers, like for half as much money than you actually did. The third example would be, of course, cores, right? A lot of scalability these days of CPUs goes to getting many cores, right? And because that is what CPU vendors are able to achieve, more cores, not faster cores, that is what frequently advertised, and that is what people buy in on. And in a number of cases, I would see people going to the system which has faster cores, more cores but slower cores, which again may be wrong choice. Maybe wrong choice because of MySQL scalability limitations, or maybe wrong choice simply because some things like running single query would only use single core instance, right? That may be limiting MySQL replication, or it only may be limiting some of your batch job, right? Which just runs queries one after another. Now, another thing on the hardware is, of course, the cost, right? And in many cases, they can say, hey, why don't you buy the server with just, let's say, 256 gigs of memory or something, and say, oh, that is very expensive. Right? But if you factor in all those factors, which can come with alternative solutions, right? Cost of more complicated development and testing, more complicated operations, which result in bugs and often downtime, right? Longer time to market for features because you have to now do more complicated development. All of that stuff could be cost much more than more expensive servers. And that is the case for a lot of companies out there. Of course, if you are, I don't know, let's say just a student doing some startup out of your dorm room, that may not be a choice. That may be just too high of investment, and you have to, just struggle through and spend time instead of money. But if you are in kind of more of a serious business, that may be quite enough. Now, something else was like not on the slide, but I thought I should mention. What do you guys think is like very common cause of MySQL downtime? What that would be? Well, in a lot of cases, I see people are protecting themselves by multiple layers of hardware failures. You know what? Well-tuned hardware is pretty reliable these days, right? And I would say, I would quote Google numbers out there, what they have done, running many MySQL servers for a lot of time, and they say what the mean time between failures for the environment is about 2,000 days, right? Which is over 5 years, right? Which is a good number, right? So that means what if we have just one server, well, it probably wouldn't fail that, right? If it's good. Now, in a lot of smaller installations, for example, I would see a lot more problems are introduced by developers, for example, pushing their own queries. We just happen to do full table scan because we don't understand how to use indexes, right, properly, or whatever, which brought system down, right, or some operational mistakes, where it was like too complicated and tables got dropped on the wrong server, so things had to be restored from backup. That again caused downtime, right? And a lot of things, both in development and operations, which come out of complication. Another thing about scaling is when to scale, right? Or I would say rather, people prematurely thinking about scaling or like a scaling out, or even like scaling up before they did some optimizations, right? And again, in some cases, people don't really understand, right, how much they can achieve by optimization, or we buy optimization and purchasing very hardware, right? And if you take a look at that, you can get, let's say, tuning settings, optimizing queries, optimizing schema. Which way of those guys do you think gives you most improvement?
The one that's not on there.
Which one?
The application.
Huh?
The application.
Yeah, well, application. But of those three.
The core optimization probably.
What's that?
The core optimization.
Yeah, the query optimization, that's right. I think application architecture optimization essentially goes within those two in many cases, right? You would change your schema, change your queries, and of course how you run. Okay. Now something else which is very interesting for me to run into is, well, in many cases you would run into sort of when you say, okay, you have to apply notification, do this and that. You would have some sort of resistance in a sense, because that view becomes too hard, too expensive, too whatever. And then the solution which is caused, fall into that problem is to migrate from MySQL to something else, right? And that could involve some different relational database, it could be some NoSQL system, which comes with a lot of re-architecture on its own, right? Because, well, it's very hard to take a MySQL without taking, changing your schema queries or whatever to run it on something else. Typically, you get some cleanup at least, right, in this case. And that's fine, right? But now, what is interesting is that in all the cases you would see and you would read as things compared as if they're apples to apples, right? Like you just replace MySQL with something else, and it works over there. While the truth can be, in a lot of cases, it's not a MySQL replacement, but it's just the proper architecture changes what gave the most advantage, right? It is just that somebody was unable to, get approval from management to just do those architecture changes. They actually had to, do a bigger part to migrate to absolutely something else to get those problems solved, right? And that may be a way to go in, your company, depending on what kind of management changes you have, right? But just don't trick yourself and understand what the things. Now, when I speak about optimization, what is the best way to optimize something? Right. It's actually in the slide, but I'm asking, did somebody pay attention? Tom, what is the best way to optimize something?
Just stop for
That's good. At least I can hope on at least one attended student in the room. Yes, that is a very big thing, and I would challenge you in a sense, right? Enable the logs of MySQL, take it to popular pages, and take a look at the queries. I can bet at least 50% of you will find what some queries they don't really need to be run for this given page. And you'll have a lot of excuses, of course. Oh, it is just I'm using this framework, it just does this stuff that is not really needed here, but it's too complicated to eliminate, and so on and so forth. And in a lot of cases, waste can be huge. Obviously, another case is what we're going to speak about more is that you can cache things in buffer. Something which is very frequently overlooked is it's possible to reschedule things, right? When something is, let's say, running slow because there is not enough system capacity, then it's often possible to run this at a different time, right? And we all, or different pace, is another. The obvious example with backups, right? Typically, people wouldn't run backups in your peak time because we know backups have some overhead and they slow down database, right? And at the same time, there are a number of other activities which could be seen in the same way. Like maybe developers running some jobs during the daytime because they want to watch them, right? If something happens. Or very frequently would be even not moving that completely in time, but pacing things out. For example, in many cases, I see people running some bad jobs which deletes a lot of stuff, right, or updates, a lot of records, which makes replication to lag. But the thing here is, if you would just, let's say, space it out so it doesn't just like run for 1 hour, but just insert some sleep software, right, in a sense. So it runs for 4 or 5, whatever hours, what is your feasible windows, but not overload the box. Does that make sense? Oh. And finally, we'll speak more about you can optimize, in a sense, optimize query and eliminate wait hours. The point here is basically what the query optimization as something what our maybe first reaction, what to do with query when we see it. Maybe not the only option, how to deal with that. Now, vacation. Vacation is very common, obvious concept. So let us check. How many of you guys use any form of caching in your application? Come on. Apple lovers, like, I see. Okay, guys, I mean, you all use caching because on some level, operation system does caching, right? In a DB, buffer pool is also a form of caching, right? It's used some way. Some of you may use explicit caching, some of you may not use explicit caching, right? like memcache, but caching is everywhere. And there are very many layers of caching, as we could see that, right? I mean, on the top level, right, you can see, okay, caching the web pages, right, for example, including in the client side of the browser. Or then going down, it will be query cache, MySQL buffer pool, and so on and so forth. Now, I would say the special form of caching is regeneration. What is so powerful about that? Well, the powerful about that is if you cache things, then you have such thing as misses. The bad thing about misses is they can be expensive, right? If my cache means that means I would have to run the query which takes 30 seconds to complete, right? But maybe too bad for a web page. It may not run or happen often enough, right? But that still means, if that happened, then somebody probably would just walk away. He wouldn't wait for that page to load, right? And it's also a question of timing, right? Not just response time, but if you have a cache, in many cases you can have too many misses happening at the same time, for example, right? Which can cause pretty spiky load of the system and all kind of like other funky terms. So in case you have a limited set of objects, right, it's very nice to regenerate the stuff. What is the cost of cache? Right. Well, of course, cache is not free, and depending on what infrastructure you're having, you would have cost of maintaining cache. And that could be development cost, so it can be, let's say, built-in cost into the system. For example, MySQL query cache is not free. There is a cost of maintaining that cache inside MySQL, and if you're not using that by having enough hits, it can be actually wasted. Now, you have to deal with data getting stale in the cache. And again, that may be your direct work on invalidating data in the cache or thinking about timeouts you have to use in your application so the data is kind of invalidated automatically. Or it may be just cost of dealing with preventing stale data like MySQL have to, if MySQL built-in query cache, right, would have to go through all the queries for all the tables which you have updated, right, and invalidate all those queries, right? And of course, the impact of cache misses, as I mentioned before, right, which could be simply too long, it could be caches called, and all this kind of problem you have to deal with. Now, what can we use for caching? And I'm not saying that is extensive fees, but that is like some examples. Static files. This looks like very old-fashioned, right? Static files. Come on, that's like 21st century. Well, but it's actually very helpful if you can put something in them and just serve directly with your with web server or even like content delivery network. I would say, the only thing BitSight is actually setting expiry headers properly, so you don't even have to do requests to a web server at all. That can be very effective. Memcache. Anybody using Memcache here? Good. So everybody knows Memcache, very common thing for cache. Again, it's the problem with Memcache. It comes at cost, right? Okay, that's development complication. It's not transparent. Database tables. Database tables are very helpful for caching when you pre-generate data. In a lot of cases, we have something which is essentially like materialized queries, right? And you say, okay, that query, we need this query resolved, but it's too expensive to run at once. To run when we need it. So we just pre-generate results to our whole table and refresh after it. Very common, very helpful. Well, they may not even call that caching, but that is, I would see that as a form. Now, we can also often cache stuff directly in the process, right, on itself. Like in Java or in PHP, you get a lot of this like Xcache, APC, and so on and so forth. Like shared memory in general. It's a whole bunch of different things you can use for that. Now, can you tell me something about what is good and bad about such cache? What is good about caching data? Okay, so Cache Wizard.
It's not global.
That's it.
It's not global.
That's right. So this cache is, because it's in process, that is very fast. Is pretty much as fast as you can get accessing that. But because it's not global, that gives us two problems, right? First of all, that means that the amount of cache is actually three problems, right? Let's say amount of cache is relatively small, it's limited to our single box, and it's only usable by what is running on that box, not by everything else, right? Now that means also what their hits, right? Like some requests which have been hits already on the cache on one box will be misses on another box, right? And the third one is invalidation, because if you have like many web boxes, it's very hard to do explicit validation, right? Because, well, some of those nodes may be inaccessible and so on and so forth, right? We cannot really rely on invalidation all the time. So this stuff can be actually good for some data either which doesn't change at all or which changes based on time and dynamics for the data. For example, if I would like to cache list of states for some reason, and if I have to store 20, 30, whatever lists of states, that's not a problem, right? It doesn't space a lot of money. And it's almost didn't change, right? When was the last change to the list of states of the United States? Who is geography expert here or history expert? Hawaii. Why Hawaii? Huh?
We added Puerto Rico as a few of the.
What's that?
We added beyond the states of Puerto Rico and a few of the.
Okay, I see.
But that
Good.
was a 20 years minimum.
Yeah, okay. So that's a while ago, right? So you can cache that over. Who has more than 20 years uptime on the server? Okay. We have cache, right? We can use speed varnish and a bunch of other stuff, load balancers, a lot of them have like built functionality for that. And what is a good thing about this cache on the web layer, like on the database level, is what it's kind of like transparent. As long as you set your expire header correct and a bunch of other options, you don't have to really manage that explicitly. But you can, right? For example, Wikipedia is a very well-known example with actually having explicit validation for squid cache when pages change, right? So with cache changes, we don't really know how frequently they're going to change, right? And they just stay there until somebody goes and edit page. Some pages can stay there for a very long time. Now, what is buffer? So when it comes to the database, when I speak about it, is like caching but for writes, right? We just, instead of actually doing expensive write, we are buffering the write in memory or doing some less expensive write, right? Database, especially in a DB, would do buffering for you already. When you change your data in DB, it writes the data in log, which is sequential and so cheap, right? And it just modifies it in buffer pool, which will be flushed to the disk at some late point in time, right? Now, what are two big benefits of buffering? Well, first of all, it allows us to delay writes. And delaying means we can get a response faster to application, right? So we say, okay, write is done, and do it in the background. And it also allows us to do writes at more convenient time, and this way deal with spikes, right? So InnoDB, for example, has a lot of special logic saying, hey, I will try to do my background writes when the server is less loaded. It's not perfect, right? It's not like we really do not very well in all cases, but it is a chance. Another reason for benefit of buffering is you can merge a lot of writes together. Right? For example, if instead of incrementing something 10 times by 1, you can accumulate those somewhere in the buffer and then just issue one increment by 10. And that is exactly what InnoDB is doing, right? If you're modifying single buffer pool page many times, it will only do one physical write to the disk. Per certain cycle. So, what can we use for buffer? Well, again, there is plenty of choices. Sometimes you can use plenty of old files. There is a lot of like queuing system support out there, like depending on the language you're using, like RabbitMQ, OptimumQ, and so on and so forth. Redis have been used quite successfully. It's not like exactly queuing system itself, but that's it has data structures which are very convenient and very fast to use for queuing. And actually, a lot of NoSQL systems, they can offer you some functionality which is helpful, right? There is Q4M, which is MySQL storage engine, which actually, if you're using MySQL for queuing itself, it can be a lot more, a lot faster, right? And especially in terms of how logging is done internally compared to some traditional things. In other cases, people just buffer in table, and that works, right? Especially if you say, okay, I can put that stuff in the heap table, right, for example, then just avoid it. But again, if you can, especially if you can afford to lose that. And in this case, I'm not saying that all those things are very optimal, but in a lot of cases, even like using some not the most optimal, but simple enough system for queuing takes you a long way compared to where you are if you don't do that. And of course, same as we could cache stuff in the process memory, well, we can also buffer things in memory. And if you can afford to lose things, that works pretty well. Now, another interesting thing here with MySQL is what in a lot of cases, especially for simple lookups, that is an SQL part, like a top part of MySQL, can cause a lot more scalability challenges than actually storage engine you are dealing with itself, right? And it's could be not only overtime but also the problem of MySQL dealing with large number of connections. So let's play the game here. Right? So how many concurrent connections do you guys have? Do you run your live? Well, the largest number of connections you run. So how many do you run?
For a single server?
Yeah, the largest.
100, 200,
What's that?
maybe 100.
Okay. Anybody more?
600 on the master, 200 on the lease by slaves.
So 600. Okay. You?
We do 1,200.
What's that?
We do 1,200 on the master.
1200. Okay.
500.
500.
I have 20 that do 2,000.
2000. Okay. But these are funny and low numbers, right? I mean, and I think a lot of you guys know, like, it's if you try to run all of connections, it will be not very good, right? But if you actually try to run concurrent transactions from all of those connections, even if it's just 500 or 2,000, then that is going to be a lot of pain. Now, if you look at the Memcache, and a lot of you use that, right? You probably use persistent connections, right? So you check how many connections we have at Memcache. What's that?
We just connected.
Yeah, but I mean, how many connections do you have? Do you like maybe know and monitor it or something? Well, and the thing is, you can have like many thousands of persistent connections to Memcache without problems, right? That is what this actually was well designed for. And that can be a problem for MySQL too, in many cases, not exactly in the SQL. So, if that is a problem for you, it may be easy enough to access data in MySQL through one of those simple methods. The MySQL cluster was kind of, I think, the pioneer in this NoSQL access, even for MySQL. I think that doesn't really ever use NoSQL for MySQL cluster. They probably just afraid to scare SQL crowd by putting that NoSQL database, right? But it actually can do it pretty well. And the MySQL cluster always had a lot higher performance for NoSQL access than for SQL access. And there are actually great products out there, like there's like special ORM mapping which can simplify access for MySQL cluster with NoSQL access. Now, if you're using InnoDB, what's his name? I'm very bad with Japanese name.
Yoshinori-san.
Well, Yoshinori-san just actually published because he can write in English. A different guy can. I think it's Ash. Well, basically that's something.
Yeah,
I remember that correctly. Well, some guy has implemented this amazing plugin for MySQL which provides this NoSQL style access to the data, and that can really get 5 to 10 maybe times more simple lookups per second than you're able to get with MySQL. And we have included that in the recent performance server release, so if you want to just try it out, I don't want to bother compiling that, so it's something you can try. Now, the next topic I want to talk about is what is exactly problem you face when you're looking at the application. And two big things here is it could be response time and it could be capacity. So when I'm speaking about the response time, that simply means that, well, I have a query and it takes longer than needed to respond. And the reasons for and that may happen even if your system is idle. Right? For example, oh my God, I'm writing this report query, I want that to complete in 5 minutes, and it completes in 5 hours or 5 days, depending on that. In this case, that's a response time problem. And the response time is always important for a sort of level. Even if you say that we don't really care about response time for something, actually we do, right? Is there anybody who doesn't care response time for something? Oh, good. Now, the capacity is a different topic, right? When I say, okay, my all queries are fast and response time is reasonable if I run them one by one, but I don't have a look at how many queries a second my database can handle, or what my response time starts to be as long as I put many queries in the system, right? And it actually, like, second is more important because it doesn't help us if we can run, 25 million of queries a second if response time for each is 2 days, right? It doesn't really help us. We need short and predictable response time. Now, how can we solve it? Well, in terms of capacity, it's very good to take a look at the database using a pQuery digest, because that is a tool which by default would sort of queries by the kind of contributing to the load on the system. And by optimizing the queries which are high in the list, you are going to reduce the load in the system and hence increase its capacity. Make sense? Come on, why don't you shake your head? Yes, it makes sense.
Absolutely, makes sense.
Good. Good. Now, if response time is a problem, then you can look at a lot of different things. Right? There's like bunch of options here. You can optimize a query, you can make it parallel, you can recreate results, which we'll already speak about, and well, quite often you really just want to design things. So you don't need such a query. Maybe you don't need this data at all, or maybe you get it in an entirely different way. The next thing I need to talk about is, I call it eliminating waste, right? Because we spoke about eliminating waste by avoiding the queries which are not really needed by the page or whatever, call. And that's not only the case, right? We can take a look at the query and see, are all results are needed? Are all rows and all columns in all those rows are needed, right? Because in a lot of cases you would find that some application fetches 5,000 rows just in case and uses only 10 of them, right? Happens. And the same columns, right? In a lot of cases people use ORM, they would join all kind of like tables, actually, right? While want retrieve the columns. And MySQL Optimizer is very better word for not very smart. So it may not always optimize things quite correct. Right? In a lot of cases, by reducing the number of columns, you can trigger different optimizations in MySQL. For example, blob retrieval. InnoDB is able not to read the blobs if they're not needed, right? You can also do things like maybe covering indexes will be used for some of them. So in some cases that is also like pain because of other factors to think for every single query what kind of columns you want to fetch in every single kind of use case. But in some it can get a lot of performance. Another question is, did MySQL actually only analyze rows it needed for it to provide the result set? Right? For example, if I'm running select on the table which gives me just one row as result, and if it happens to scan the whole table, so that is done, right? And that means that I probably can do something to maybe add better indexes and so on and so forth, right? It's not always possible to have it like one-to-one relationship, but that is a very helpful metric to compare the amount of work which system has to do to actually complexity of results you need, right? Because we know in the best case, if you just recreate result and put it into the table, I will have one row scanned per one row return. You can also look at that stuff from other factors, like for example from disks. Disk issued to the disk. A read issued to a disk actually had to be there. In a lot of cases, you would see you would find surprisingly many IO requests for some kind of queries. And that's actually some data which is available on per query in one of the instrumentation that is in Performance Server. But that is very helpful to understand because in a lot of cases, IC people don't quite really understanding how caching works, right? Or maybe having some misconceptions what they think should be cached as what is actually cached in MySQL buffer. To give you an example, maybe they just run some, I don't know, let's say, batch job which does a full-scale table scan and then, washes away a lot of stuff from buffer, right? And they think, well, I'm only touching the small data set, but actually they're doing a lot of IO while doing that. And the best way is not to guess, but to check, right? And I think that is a generally very good rule because, I'm constantly myself find out what I would think would be the case is actually not the case. Something I forgot to think about some other factor out there, or maybe customer didn't quite tell me about something they're doing, and that causes things actually working differently than I would expect them to. And the best way not to come to this trap is actually measure. Right? Not to guess by measure. Another statistic response to reads also has to do with what kind of data you're reading, right? Because in a lot of cases you may have some columns and rows which are read, which is not being used. Like for example, choosing proper InnoDB primary key may help us with clustering, and so we are actually accessing a lot more helpful data compared to just like data which is not needed by the query. Empty deleted space, again, depending on your life, there could be a lot of junk in between the rows, right, or in between the index entries. And that's very helpful to understand what is going on. Now, what if you have a query which scans 10 million, 100 million, whatever, pick your number of rows? And that is query with inherent complexity. Like a lot of reporting queries are frozen. You just kind of, if you want to do stuff, you have to analyze a lot of data to get results. So what are the choices in this case? Well, is it feasible to pre-create a cache, right, this query? That may be very good option. And again, you have to carefully watch for our response time, what happens in case of miss. Can be run in parallel. That is another very good option. Right? We can use in some cases, let's say, split the query running like kind of multiple jobs in parallel with Gearman. We can use like shard query, which is something one of our guys have written, which is sort of poor man's kind of entirely application query, application level sharding solution. In MySQL ND, you can issue multiple queries in parallel and on different servers, right? Or even like on the same server, different connections, and then wait for results to complete, right? And then aggregate those results. And there are other solutions as well, right? If you're using like some languages support threads, you can just issue multiple threads and then aggregate the data and so on and so forth. Now, the next point here is, of course, going beyond the single cell. And I'm going to speak about the three different things here: replication, which is most known, rather than functional partition, and sharding. Well, what about replication? We get one slave, we set up a few, one master, set up a few slaves, and then actually we can linearly scale our reads. We have 10 slaves, we can get 10 times more reads, right? So what are the problems with when we use a replication skill? Well, replication is asynchronous, right? That means that there is a potential of reading stale data. And that is especially dangerous because in many cases in development environment, it may be kind of impossible for developer to get replication to live. I write it here, I read it from there, oh, it's there, right? Unless you use some special tools to simulate logging or something, right? In your development environment, you just wouldn't see that. And that means a lot of applications are done where they don't really deal with live properly. Right? I've seen people which use replication, and unfortunately it's simple enough in MySQL so everybody can set it up. So they use replication without actually understanding that it's synchronous. They think it's, it's just synchronous, right? And then things blow up and something. Now, another concern with so point is you have to deal with that. One of the ways, selecting your queries or having some version control in a sense, so you know when it's safe to read the data. Another problem is, of course, data replication. Storage it can be cheap, but high performance storage is expensive, especially if you are using SSDs, right? So the fact that if you have like 1 terabyte database, store 10 copies of that means 10 terabytes extra. That can be expensive, and not just on the disk. The cache is also going to be highly duplicated, right? So as my data size grows, I will be actually having slower because the memory on my slave boxes is not kind of going to really it's not going to help because it's going to be all duplicated. There is a lot of little tricks you can do. Like for example, I can have some sort of persistence on the slaves, right? Say it could be different roles, right? If I'm having a reporting queries, I may run them on slave A, while my different kind of queries are run on B. In this case, we assume that all reporting queries in general have a different working set than in general, let's say, interactive queries. And we'll have a better hit rate, right? And now a way would be to look at some persistence on the user level on session level. So even if I don't use sharding for some reason, I can say, hey, what even users go to route it to server A and pod on server B. Or maybe even better choice to do that on the per web session level, right? Because if for a lot of applications, people can go on site back and forth, right? You go there, we get back to the profile and so on and so forth, right? Maybe if you visit a bunch of friends or whatever, right? It's essentially the same group of people, right? And that applies to pretty much any websites. They all have our favorite spots. So if we can cache this stuff on a session level and understand what that's session from A route that to a given host, then it may help us a lot with improving caching. But what is important here is when you cannot get the you cannot completely eliminate duplication of cache. It's going to happen, and especially and at least because there is some write traffic. And write traffic is going to be run on the old slaves the same and is going to bring up some stuff into the cache. Now, another big problem of replication is single thread. And what was happening over last few years is of course that we are getting a lot of CPU cores these days, right? And also many hard drives inside the case, right? It becomes more affordable. So right now it's very easy for me to get the box which has relatively inexpensive, right? Say 12 or I have 24 built-in hard drives. So it is easy for people to have a lot of cores or a lot of spindles. But what is really important about those, right? Well, all those things, they only offer you performance if you can have multiple outstanding requests execution. Right? If you have multiple threads, you have multiple IO requests running at the same time. Well, MySQL replication runs by running a single thread, and it issues IO requests one after another in most cases, right? So what that means is it won't scale. Practically in all applications I've seen, you would see you saturate a replication thread between, let's say, two boxes or the same configuration a lot faster than you're able to overload your master thread. And that could be like replication capacity could be easily 1/10 of what you're able to write on the master and compile into the installations. So the holy grail here is to have replication done in parallel. Well, and there is, I think, some proposal or a workload item for parallel replication for a few years out there on ForgeMySQL.com, but it haven't been implemented yet. Right? It's not really clear when actually get a working solution. So far, I would mention like three approaches here. Right? If you're really using MySQL replication, you can take a look at the tungsten replication by continuum. They actually have a parallel replication which is, in some cases, maybe faster than single thread MySQL replication. Right, so that's one thing to take a look at. In a lot of cases, you can be nasty and think what for some operations you may not use MySQL replication, but take them kind of separately, right? Handle them separately, for example, store the MySQL table and then apply the changes separately on the master from your working thread. This can be especially helpful for some longer batch jobs, right? If I'm going to archive my data or delete a lot of data, which is expensive operation, right? But I don't really care. If I'm planning to delete the data after a certain point, I often don't really care if it happens at the same time on master and slave, right? Instead of doing that on the master and let it replicate, I can just do it on the slaves directly instance, right? And I also should mention that we are looking to do kind of like native parallel replication for MySQL 5.1. So if there's like anybody would benefit a lot from that, let me or Tom. No. Tom, I mentioned your name. It's fine, please. Okay. So what is about replication performance, right? I think it's the most important for us to really know what kind of replication performance we have, because really the difference is not large between the replication which kind of never falls behind more than a couple of seconds and the replication which is never able to catch up. If your load is very uniform, it may be just like 10% load increase or 10% increase in the database size. You may very quickly find a situation as, oops, my system as a replication is not able to catch up, right? Now, again, in Performance, we have an instrumentation which can show how much time replication thread is loaded with its item. And I think MariaDB has that this as well. And that is very helpful to monitor, so you know actually is your the replication capacity is used 30%, 50%, 90%, right? The second thing is what I would suggest to take a look at is to take a look at their the queries, right, which limits replication performance. And again, we have ability to log slave queries in the slow query log, which is very helpful in understanding what kind of queries are loading your replication. It's very interesting, but in a lot of cases, I've seen that to be absolutely surprising for people which queries take long to replicate. Because these well may be queries which are different from queries which took a lot of time to execute master. Because, for example, in-memory contents may be very different, like in cache on master and slave. Now, another thing is, which is helpful to know is MD slave preference. I wouldn't suggest to really rely on writing that too much. But then you forgot about those like 10% of your replication goes into mode and it's unable to recover. And key-slave prefetch for a lot of cases can give you those like another 20, 30, whatever percent, so you can figure out what to do next. Right? Now, what else our replication is good for? As I mentioned with 37 signals example, for example, some people choose not to really use replication that much in production for scaling. But replication is still very, very good, right? You can base your high-ability on replication. And I think even though that's kind of not perfect solution because it's possible that for some transactions being lost due to a simple replication, well, I think that is by far the most popular high-ability solution for MySQL users. So how many of you guys use MySQL replication for high-ability? Okay. and then DRBD, or like SAN. Something else? What's that? Yeah, but MMM is based on replication, right? It's that's right. So DR, keeping the slave in different data center in case shit happens, or having delayed slave if different kind of shit happens. For having slave for analytics because we may not like to run our complex reporting queries right on our production system. And by the way, it's possible to do to run different like storage engine like on the slave as well. It's not very, it's not for everyone, but it's possible to do in some cases. For developers, in a lot of cases, like the very good way to avoid your developers kind of like testing their queries on database which has just 100 rows is actually to give them a slave production database. Because in this case, they at least can try the select queries and see some real results. Backups. Again, a lot of people choose to do backups from the slave. I mean, if it's possible for performance reasons, I would prefer to do it from master because that's when you're backing up the real thing. But in many cases, the overhead is too high. So we'll take backups from the slave. And in this case, I would warn you kind of to make sure the data is in sync in master and slave. Because I've seen a number of cases when people would back it up from slave and then they figure out their backups are not good because the application actually got broken 3 months ago, nobody fixed it, right? Or maybe it wasn't broke, but they actually have slave skip errors equals all, and they dropped a couple of important tables on the slaves because, well, it was also used for something else, right? I mean, could be all kind of things, right? And you have to be really systematically checking things, and that can be done well with MK table checks, another tool for Matkit, which is you can do it online, right? So you don't have to like stop everything and check something. Another thing that replication is very helpful for is sort of like online schema update, right? So adding the index for MySQL, or adding the column, or doing other good kind of stuff like even optimizing table, well, it's very painful and can take a lot of time for longer time. Let's do another test here. So how long was your longest alter table state?
What?
Longest alter table. How many days?
8 hours?
I've had one take 24 hours.
24 hours?
5
More?
days.
What's that?
5 days is the best.
5
I've
days?
seen.
Any more? Come on, guys.
5 days,
Is
that's
there-
very hard to beat.
What's that?
So mine actually failed a couple months before it succeeded for 24 hours, so we discovered it was a unplugged battery on the RAID card.
This was just one day.
No. So, well, that's right. I mean, I've seen that also to let taking days and in a couple of cases could be a couple of weeks actually, right? I mean, so it can be very unpleasant to really do that in production. But if MySQL replication is possible for you to do that on the slave, then fail over to that slave and then repeat the process on the master. Of course, it takes several weeks. It's not pleasant either, but well, I think it's better than having a few weeks of downtime, right? Now, if you use this style, I would suggest to check the MMM, MySQL master. I think it's very handy, especially for, let's say, upgrades and all this kind of stuff. Now, what is... how is it time? So, what is functional partitioning? That's it?
You're okay with that?
Okay, okay, good. Because even when I do a few slides, I tend to talk a lot. I say, no more than 30 slides this time. It doesn't help. Okay. So, what is functional partitioning? Well, that is when we get some different functionality and just place that on different database boxes, right? Now, what is a good thing here is if you're designing something, try to at least not to add too many like cross references with the data because that may be very hard to decapsulate. And what I could give as a simple example, we have like a main site, there's some blog forums where there is no inherent dependency between them, right? You can put them on different boxes and then get box scalability if you need that, right? Fault tolerance. For example, if server which hosts your log goes down, your website doesn't have to go, right? It's eternal. Right? So that is good. Of course, you may have something, oh, I have, let's say, last blog post on the front page of a website. So if you would have it on a single database, you may introduce some cross-dependency, right? But you don't have to do that, right? And you could have it start fetching by a different query, like instead of some form of join, right? Or even store that on a regular basis in Memcache or table, right? So you don't really have those dependencies. Now, what is the problem here is that typically you don't have that many functions which you can spread, right? So if I'm saying, okay, I want to scale 50x, let me find what are those 50 functions in my application which I can put on different databases. For most, that will be very hard. And even if you are able to do that stuff and isolate those 50 functions, you'll find what 1, 2, 3 will be responsible for majority of the load, right? And that would be impossible to use this technique to scale further. Make sense? Now, sharding is an interesting thing, right? Because sharding can be easy and sharding can be hard, right? And that is important to know because some people get kind of offended if I try to say, hey, sharding is hard. So, no, sharding is easy. It's easy in the cases when data doesn't really need to be in a single database in the first place, right? For example, a lot of software as service companies, they have different customers, and actually keeping them in a separate database is a good thing. Not just for performance, but for a lot of other reasons, like, for example, security, right? And in being able to back them up and restore independently if they screw up something in their data, for example, right? And ask you to restore. Well, that is possible, and well, it's easy in this case, right? And I wouldn't like to really even call it through sharding in a lot of sense. And in your case, if it is easy, sharding is possible for your application. It doesn't really add development or operation complexity too much. Of course, it always adds something, right? You have to have, let's say, 25 schemas, and you have to run either table to either index, you have to run it 25 times, right? So you have to script it properly. But it's not that a big deal, right? It's not as big of a deal as writing 25 queries instead of one and actually doing manual joins. Right? In this case, it's good not to add dependencies without a thought, right? So if you can keep things easy, do that. And if you can implement something you started early in life, then you may be able to get all the sharing benefits in actually slowing you down and increasing complexity and all other bad things exposed. Now, for most applications, which are like more tightly coupled, yeah, that's almost sharding is not so easy. And what that means is when we are sharded, when there is significant complexity. Development, QA, operations, so on and so forth, right? What I would suggest in this case, well, of course, as you start your application, think about the sharding. Even if you don't really shard it once, it's good to understand how you're going to do if you need to do it, right? Now, I also suggest not to rush into the sharding unless you clearly understand what you need that. To really be safe here, you need two things. You need to know your capacity, right? For example, you can say, hey, you know what, I have just 1 million of users now, and I know, I'm confident my thing is going to handle 10 million users before I have to shard. Then from that, you can understand, right, but well, we're not going to 10 millions of users in the next 3 years, so you know what? Let me wait for the next VC round before I can, let me wait. They invest a lot of time in this sharding, right? And of course, this also means that you should have least some understanding about how many users you're going to be. Now, if you decided to shard, what is important? You want to preserve locality access when possible, right? So, for example, sharding by user is good in many cases because a lot of accesses, they are retrieved data based on given user, right? A lot of queries can be run just locally within a given shard. Now, even largest shards should be manageable. So, for example, if I take where some large application and shard it by country, well, it may be good because most of my accesses are going to be local, but it may be not enough because there's some pretty large countries, US, China, which may not be fitting from performance standpoint to single shard. On the other case, maybe the sharding by state and city can be good, right? Especially if it's, let's say, some real estate company which is actually operating just in the local market, right? So there's like no cross access. Now, sometimes you may choose sharding by multiple variables again to speed up access. For example, you would have some site which is like social site around movies. In this case, there are like 2 million access partners. You need to access by user to see, for example, all movies that I have seen, right, where you can store. And then you have to have an access by movie to understand its rating, what users spoke about that, and so on and so forth, right? And in this case, you can just double store information. If you do it right, then it's not very scary. And I can say here is what we don't have any like database luxuries, well, which doesn't scale very well anyway. Right? Things like foreign keys don't really work between shards. Distributed transactions are expensive. What is good here is to implement in some form of queues, right? So if I shard by movie and by, let's say, by user, then I can store my local queues in my user database, do it right out there, and then do it kind of in background to replicate to the movie database. Does that make sense? Now, the types of sharding. Well, you could see some people sharding pretty much hardcoded way, right? I put some data, even users on one server or on another, or I could divide by 10, whatever. So, how many of you use that technique? Anyone? Like this sharding, which is fixed. Let's say even goes here, won't go to different servers. Pretty much fixed hashing by server.
I've seen an implementation of it.
What's that?
I've seen an implementation of it. That is a stay away from that.
What's that? Yeah, I mean it's not very flexible. There are some hacks with consistent hashing and so on and so forth, right? And I actually have been dealing with one last week. It was pretty funny because they run into a problem that the boxes are overloaded. So now we have had another complication code. So we have to split all servers in two, and some of them, I don't know. So now we divide by 4 instead of 2. So it's nasty. I think for most applications, what you want is some sort of dictionary access, right? When you actually, if you have a user, so you know what user A lives on shard 25. Right? And what is good here is what you can store a bunch of flags in this dictionary besides this data, some metrics about how many users or whatever. And it's very scaled, right? It's very cacheable because you don't really move things around that frequently, right? And you can replicate that if you want, and so on and so forth. Right? You can feed in a MySQL cluster, and there's also some exotic tools you can do. Now, we're almost right here. Come on, give me a break. So, is there somebody who wants to go home?
You want my question and answer?
Yeah, I know. But they just room till 9:30.
Well, we have the room till 9:30. We got to just schedule it.
Yeah.
Okay.
I know. Got it.
Yeah, the 5 guys who got their session, if they want to.
Oh, I see.
I want to pull them during the session.
This is actually a slide before last.
We just have 2 other people scheduled at 8 o'clock, so we need to make sure that they. So if I could just get the 5 people who wanted to pay $50 to come and get Sorry, Peter.
That's fine, it's fine, that hour. No one wants to go, okay. 2 minutes. Okay. We have to be responsible to cost, right? So, and we have to blame Tom, right? Because I was planning to run into my 1 hour, 15 minutes, but Tom, first half an hour. And everybody, how great your company is, right? So, where do you want to implement Shard, right? It's to be application database layer. There are some ORM frameworks which may support that, right? And if you have something ready which works well for you, that's good. I like the database access layer because even if it gives you a lot of work, it actually gives you a lot of transparency. It's kind of like you see a lot into that and kind of you feel the pain when you do stuff, which is helpful from a efficiency standpoint. You can also do it some way on the proxy level, right? And proxy, I mean, it could be like MySQL proxy or like Spock proxy is based on that, or it could be like shard query, which actually also gets a query, then it kind of analyzes it, rewrites it to a bunch of other queries, right? And it aggregates results. So that's like, what was it? This is kind of nice and seems easy, but in this case, it's not so transparent, right? So you can have like some unexpected side effects, you may not know what's really happening inside. That's it. The last one is sharding and tables. Now, when you look at the objects, for example, users, right, customers, which is shard, or like I would call it sharded kilos, we can have multiple choices. We can put each of them in its own database, right? And this is actually pretty good if there are a few users, like as I mentioned, enterprise software service companies very frequently use this approach, right? For security and all of other things. Well, the problem in this case is, of course, if you have many users, right, and because many databases and tables, MySQL doesn't really like it. And some people ask me how much is many. I would say, well, probably over 100,000. That is where I would throw it many. Now, another approach is to have like one database per instance. So I have my database, my application, and it has a bunch of tables where everything is stored. This is especially used for retrofits. When I had my Node-RED application, I'm saying, okay, I don't really want to change my query. I'm just changing where I'm going to run the query. I'm connecting to the same database, just on different boxes and kind of running the queries. Now, this helps to do less things in the code, but database and tables can get pretty large, and that's not convenient to deal with. What I prefer is having some sort of mixed approach. When you have multiple tables with different databases, each having many keys, right? So I can select if I want to just have one table, right? Or if I want to create one table per user, kind of dynamically. Then in this case, I can find out what is the optimal balance and store many shards on the database box. It also has some like simple things like backup and restore are faster. Alter tables are also a lot faster, right, because you have some small data set that fits in memory. Right, and other stuff too.
So before we go into Q&A, just first want to thank the wonderful people who arranged all this to happen, New York City Technology Ladders. Also want to thank our sponsors, which is British Airways, Fork Enterprise Framework, and the Ladders. So for the guys who want to do the pizza at $50. Yeah, wishful thinking. Pizza at $50. Now's the time. Anyone who wants to default, then I'll just give a hand over to someone else. You mentioned that. Yes, no?
For me?
Yeah, you said you were. Weren't you on the seats?
How many people want pizza and $50 for an hour's worth of work? Raise your hand. We got one. Everybody else? Needs $50 for an hour's worth of work.
I'll do it in 15 minutes, but not yet.
Sorry, need for an hour. Anybody? Do we have one? Do I have another 45 minutes worth of work? Any takers? $50. That's an iPod Shuffle. That's 10 of your own pizzas. It'll be a good time. It'll be fun. 45 minutes, $50, and oh, we got two. Come on.
5 minutes. Give me 5 minutes.
Give you 5 minutes.
Here.
Okay.
Before you start.
Sure.
All right.
Any other takers before I go on? Okay. About, I don't know, 8-9 months ago in one of our sessions, I did like a show of hands of which databases does everybody use for survey. I'm curious because the industry changed quite a bit since that time, so NoSQL was mentioned briefly in the middle. So just before we go into Q&A, by a show of hands, who here uses any form of NoSQL non-relational database? Oh, wow. That's a lot different than last survey. Okay, let's start breaking that down. Redis, because that was mentioned. Wow. Hadoop. Mongo. All right. Did I miss any that are used? Couch, of course, Couch. Couch, hands. Apparently the two people who mentioned it are coming to you, so okay.
Memcache, the
Membase?
DB version, yeah.
Membase.
Membase, yeah.
I don't think that's in production yet. I think it's beta. Oh, it's out? Yeah. Okay. Does anybody use it?
We used the beta for quite a while, but it just wasn't up to snuff for what we needed it for. We were worried about it.
Cassandra?
Cassandra. No. Okay.
There's like Voldemort, I guess.
Voldemort, that's right. Nobody? Tokyo Tyrant? Nobody? Okay. Not the big sellers, apparently. And then relational stuff. Obviously, we're all MySQL users here, so let's just skip over that one. Postgres?
I used to.
Used to?
Enterprise DB when they were betaing, we did as well.
You're the only one who over. Wow, that's surprising. That's not very much. And I used to. Wonderful. Okay, let's start. DB2. That can't be a big seller. That's a dead one completely. Will Sybase do any better? Yeah. Okay. Use that.
Yes, my created project on Sybase.
We're migrating from Sybase to MySQL.
Nice. Okay. Did I miss something?
Well, let me ask, like, what about master data? Master data? That's like for OLAP or analytics. Scalable, like.
Well, before we do ACID data, does anyone use OLAP? Because that's probably the prerequisite for. Yes.
But they mentioned Hadoop, right?
You're talking about processing, not specific.
It's just a survey, whatever you want to interpret it as.
Through SQL Server and
Oh God, yes. Oh, Microsoft. Yeah, right.
Oh.
Microsoft SQL Server.
Oracle.
And Oracle.
Who uses Oracle?
I can't believe I missed the big one. Okay.
And sorry, we talked about MySQL, but I'm curious. Does anyone have used MariaDB or
I actually migrated.
Percona server?
Percona.
There's the Percona server people, which is good. And Drizzle. Okay, well you've got it. So right, InfinityDB.
Cool, right? All right.
What about plastics?
Which one?
Plastics. Use it. Have you tried it as well?
We have another production.
Oh, really?
You have about 5 nodes in production and a 4 node in QA.
Well, let's start opening up to. This is fascinating, by the way. But let's start opening up to Q&A because I think everyone's interested in that. Who wants to go for the first question?
You want to?
Computer considered the performance block.
Oh. You want to mention? Yeah, we have a small blog, MySQL performance blog.
That's it? Oh, that's easy. Okay.
Do you want to give Tom and Navid 1 or 2 hours to talk about MySQL performance blog?
Well, hang on. Let me at least plug it. I have to say that is the best resource for MySQL high performance, serious, hardcore DB stuff. It's the MySQL performance blog. Questions? You were about to fire one.
So we have a situation where we have a lot of tables in one database. So we have like, let's say 10,000 logical databases and over 100,000 tables. They're all small.
Altogether, right?
Altogether. But we're running on MySQL 5.0 because we're using it Ubuntu LTS release. And it's very sad and slow when we want to create tables or change tables, alter tables. Would we get much better performance going to ReconaDB or something else?
I think it's a good question. Why is it slow, right, on the first place? Because, I could see a lot of things getting slow, but honestly, in a small table, right, it shouldn't, right? And I understand what it is, but it's not clear what is causing the problem. Maybe like your
Well, the issues with MySQL doing some kind of a directory scan for.
Oh, you mean when you do a lot of them, or what?
I think anytime you access the information schema.
Oh, the information schema. Well, the information schema is slow, right? So I mean, there is not much you can do about getting information schema faster, but you don't really have to access information schema to alter the table, right? And one of the things you can do is, let's say, show tables is a lot faster than selecting from information scheme because it does actually pull up all this kind of stuff. So if you can do show tables and then you find the table which you need to do alter and then write alter on that, or like even like try and show create table or kind of point select information scheme to get data just for that table will be the way to do it.
Wait, I'm just curious. Were you the person before said they're using Cake? Because Cake does that exact problem that you're describing. Okay. At least by default. Yes?
You mentioned that the MySQL Optimizer is not so... Okay. Don't have to speak quietly. You mentioned that the MySQL Optimizer is not that good. Do you know how other optimizers from the MySQL forks compare, whether it be Drizzle, MariaDB, or Percona?
Yeah, so let me say, so the MySQL Optimizer, right? So I honestly cannot say how much work was done on the MySQL Optimizer in Drizzle. Is there any like big changes in MySQL Optimizer for Drizzle?
If you're asking me, then
yeah,
no.
I'm asking you.
So I'm just standing up because I'm sick of sitting. No, not right now.
Yeah,
but
I remember that is a big piece of. Okay. So it's very hard to do changes to MySQL Optimizer because it's very kind of big monstrous piece of code which was accumulated a lot of weight over the years. Now in MariaDB 5.3 they're doing some changes to MySQL Optimizer to optimize certain ways of subselect faster. In Maria, I think it's 5.2, they already did some changes to Optimizer, how it works with views, so it can handle certain views, certain views there. But with Optimizer, you have to understand like what exactly your, whatever the problem is, right? Because in many cases, it's not even MySQL Optimizer problem itself, but some related issues. For example, in the DB stats are pretty volatile, right? You can get one, and then you refresh the stats, so you kind of get like 10 times difference. And the optimizer starts to choose the different path, right? And there are ways to deal with that. For example, you can increase number of pages in the DB samples, right? Or this kind of stuff.
Peter, is it worth noting that most of the original optimizer development team joined the Monty program and was working on MariaDB?
Yeah, that's huge. So most of our optimizer team from MySQL now works on MariaDB, so that's why we do optimizing.
They work with MariaDB, which is the company founded by Monty, the creator of MySQL. Next question? Question? Yes?
I don't know, what's the difference between MariaDB as they ship it from a server? Or is there a difference? Do you base on Maria?
Yes, so now we base on MySQL, like same as MariaDB now. And we have like our own set of patches. Some of them are in different versions of MariaDB, some of them are not. Like the biggest thing I think this is XtraDB, right? That is our improved version of the NetDB storage engine, and that is included in MariaDB. So I can tell that we are working with MariaDB team and Maria to kind of.
Well, do you guys include the Maria storage engine itself?
No, we didn't include Maria storage.
Because in MariaDB, that's used for town tables by default.
Yeah, so we didn't include Maria storage. That's right. But there is a lot of work that we are doing with including our patches in MariaDB some later versions. So.
Peter, isn't the short version, the short answer that MariaDB has a much broader focus than Percona Server? Percona Server is a much more targeted and limited set of changes.
Yes, that would be fair to on. But I would say at the same time, Tom, right, there are certain changes that we have done which are not in MariaDB 2. So we have like more narrow focus in scalability, transparency, right? And with MariaDB it's a lot, and I think it's our goal is very comparability with MySQL, right? By default, that is sort of the biggest goal. So in other cases, our approaches differ, right? For example, if you have the base on, let's say, Percona Server of MySQL 5.1.53, right? That version means that we, unless you enable some options, we want behavior to be exactly the same, right, as in that version. So it's very easy for people to migrate. And that means that we are going to be, let's say, I would say it's like back-to-back comparable, right? Let's say we're having cases when MySQL, for example, introduce optimizer changes in later versions. We would follow that, MariaDB wouldn't follow that because I think the changes are not good, right? And in that case, we may choose to implement some options, right, for behavior choices, but we believe for most of MySQL like users, it's good kind of to be able to run in exactly the same way as stored in MySQL. Does that make sense?
Peter, can I just add to that? So two of the advantages that Percona gives you over the MySQL product is one, more instrumentation, and sometimes just exposing information can really help you in like optimizing queries or something that's going wrong. And the other thing more in the earlier days is you would expose the ability to change some value which was hard-coded and there wasn't a variable for it. So there were two things where I would identify, you didn't mention it, but I would identify as strengths of Percona.
One of the cooler things of XtraDB about using in the past is the save in a DB buffer. Very useful. Save in a DB buffer. It dumps the addresses of the pages to disk, to a file, so then when you restart the server, it comes up cold. But you can tell it reload the same pages out of the NODB file or files. So you go back to a not so colder box effectively. Now it could be twofold. If you have to reboot the machine itself, you're going to lose your disk cache, which will help you a lot. If you're just restarting the box and you have ISIN tables, but with this, you get the ability to just reload all the pages and you're back up to almost the same point. There's a very neat graph on the Percona site that shows the recovery time of the restarted server.
Like a persistent cache almost.
Not really.
It's bringing a call system up to being a whole system fast.
Yeah, well, I think in other cases, it's like you can't actually serve the traffic with cold systems because it just take it too long, right? And you can do it like manually, say I primitive some queries, but that is like, that's a pain, right? And that just takes too much time. And in our case, we serve the contents kind of, or identifiers of pages which are in buffer pool and then we load them, right? So it's actually in the state as the variable is in the state as loaded.
Yeah, I'll ask it after.
Okay, yes.
Yeah, I have a huge table which currently it has 4 billion rows. It could be potential to grow to 7
What is it?
4 billion.
4 billion rows, okay.
Yeah. It could be grown up to 7 billion.
Okay.
do you have any recommendation on how to build this table? For example, data engine or yeah, I already.
Yes. So the question is how to deal with a table which is larger, 4 billion rows rather than growing to potentially 7 billion rows. Right?
Yeah, 7 billion. 4 billion currently it has it is about 500 gigabytes.
Mm-hmm. Yeah. So well, I would say it's a good question. Like, what exactly is the problem, right? What you're facing with that table. I mean, in a sense, well, that is a large table, right? I mean, it will have performance of a large table. Whatever we have to do something with that depends on what's the problem, right? With goals.
What storage engine is it in?
Right now we use a plugin, InnoDB plugin.
Use NODB. Okay.
Yeah, InnoDB plugin.
Is it slow in insert? Is it slow in select? Is it keep the back up?
It's probably slow in both.
Well, 4 billion is pretty big. What is it about 7 billion that makes you think it's going to go off a cliff and 4 billion didn't? I guess that's
What is it?
4 billion is pretty big, you know, as is. So what is it about 7 billion that makes you think it's going to, you know, decrease in performance where it hasn't for 4 billion?
It's twice the problems.
Pardon?
It's twice the problems.
Depends on what the access is. If it,
Well,
yeah.
I would say one thing is don't use int for after increment. That's like a funny. I just had a customer which had this like similar problem, but they just discovered what they're using int for a bunch of like after increment and were like 3.9 billion or something. And now we have to very quickly have like sleepless nights, do like alter tables, all this stuff to get everything to begin.
So the biggest problem is not actually the alter table. I mean, even if you can incur like 3 days to alter the table, the problem is if you weren't using the plugin, you would need twice as much disk space and it would not be reclaimed. And assuming that you're using the plugin, so that at least file per table, that space will be reclaimed.
But I mean, file per table it doesn't require plugin.
No, what I'm saying is that people have large tables in InnoDB and they don't realise that the secondary impact is if you alter the largest table, you need just as much disk space available to alter the table because it creates a copy.
Yes,
and
mean,
people don't realise this.
If you use single table space, that's it.
Yes.
Okay. I need to file per table.
Questions? Somebody?
Nobody else.
Go for it,
You mentioned Hamper Socket
Huh?
somewhere in the presentation. I also saw that I'm planning my sequel today.
Mm-hmm.
Can you please elaborate a little bit on what that is and just...
Okay, so the Hamper socket is like another interface to access data in MySQL, right? So it listens on the different port and it speaks different protocol, right? Than MySQL. It uses pool of threads, right? So it's kind of and it's something like event-driven communication. So it's in this case similar to Memcache and a lot of those guys. It has its own little API which allows you to select on the tables, right? So and get the data out, which bypasses SQL parser, optimizer, and it's bypassing a lot of like this login overhead, because kind of can sort of amortize across multiple queries which you go in. Right, so that's how it's how it works.
Only for NODB.
What's that?
Only for NODB.
Yes, so that's works only for NODB. That's right.
Draws directly to NODB.
Yeah, and in NODB, in Percona server, that's obviously extra DB, which is going to be used. But I mean,
Questions?
What is the life? So I've got a quick question, and this is just on the outside. I mean, we're using Postgres right now. For a long time, it was like they were kind of neck and neck. Is MySQL just head and shoulders better now than Postgres?
you know what? I think the better is a complex world. right in this case. And I can tell that we are not claiming ourselves to be Postgres experts, right?
Yes, we are.
What's that?
So yes, we are.
Yeah. So I know what's like. What I can tell, right, was what Facebook got. They have been testing a lot of that. And I think that's sort of like constant change. Maybe at large extent to kind of nudge Oracle and say, hey guys, improve because PostgreSQL's guys are getting better, right? But I think it's still MySQL is a little faster for SQL queries. Postgres had a lot more advanced optimizer like forever. So if you have something like very complex query which require, let's say, hash join or all this kind of like stuff, and Postgres will be faster, right? So that's, I guess, not a surprise. A lot of cases what I still hear about the Postgres is not just performance, but kind of stability of performance, right? Because if you look at the performance of this kind of background activities and so on and so forth, you only can have as much traffic within the system as you see performance in your values, right? The slowest point, and that is, I think, where variance in low what Postgres can handle was higher, right?
The other thing about Postgres is that you don't get the very easy scale out because there's the only replication that's built into Postgres is function. So it's like always recovering Oracle server where it's going to be either read only or you can make it read write, but then you lose your spot. So you have to resort to Slowly, which is the asynchronous trigger-based replication, which is an amazing pain to manage. When I was using it at Vonage, we actually had it fail at about 90 gigs where it would not, because the way it retrieves the data is it does an effective dump across the database channel without, instead of just like copying all the files and spinning out to the server, it literally sucks all the data into the file over the database channel. And that could take days. So then I'll have to catch up from that, and then if it fails, it just starts over.
Okay.
But if you're doing things like GIS, I would say Postgres. Yes, Postgres does better GIS than MySQL. That's just what it is.
Mongo has it too now.
Postgres has better.
It does. Mongo is very limited.
Postgres also supports partial indexes and
table inheritance, things like that.
Table inheritance. Postgres. That's their hacked partitioning, which needs extra massaging to actually maintain. But my favorite feature was partial indexes by far.
I'm sorry, what's it?
Partial index?
Yeah, partial index is always pretty good.
Yeah. So if you have it looks at the word clause and you can create an index with a specific word clause. So if you have a lot of, say like a bunch of ones and then 2, 3, 4, 5, etc. with limited numbers, you can do where that column is not equal to 1, and it'll create index on the values that are not 1. So you have a smaller index, and it'll go straight to that index.
So the index has a subset of the information.
Yeah, which goes into the optimizer itself, and it configures that path. And also you're not limited by there's a lot better index join, or I'm sorry, not index join, but index merge, where in MySQL you're limited to one index per query per table.
Well, I mean, it sounds like one index, there is an PG index merge.
But it's finicky still. Postgres did it a lot better.
Yes. This is just something I heard yesterday in the conversation. Is it possible to index a text field if you index a portion of a text field for text search?
So you
It
want
might
to
be no, and the answer might be no. I'm
not sure what's it.
Well, this is something we're having a conversation about. Actually, we're comparing Postgres and MySQL for full text. We didn't want to go out to Lucene or Lucene and Solar or Space, and we were trying to see which one was better.
This is a big plugin. There's Sphinx plugin for MySQL. And Sphinx will actually now speak MySQL, so you can connect with MySQL client to do queries against it. Yeah,
I would say the MySQL full text search is kind of, I can show you a lot of cases when like will be better than MySQL full text search, so to speak. And it's not very scalable, right? And it's also like MySum only. So I would take the full text search which is built in MySQL.
If you try to do any form of real, actual searches, it's not really going to be comparable to like Sphinx or Solar.
Well, actually, we use Solar. We were just, as you can't just say I use MySQL. You have to continually compare it to other tools to make sure you're going in the right direction. And that's what we were doing. Just for that.
Just the stemming aspect is enough to warrant using a tool, a search tool.
That's the one we Solar.
Yeah, I think with this stemming, actually, you have like this full text search, full text extension plugin where you can do some sort of stemming in MySQL, but that takes some work, right? It's not like just say, okay, this is I want English stemming on this thing.
So that would still require MySQL, right?
Exactly, yeah. MySQL.
Question? Also, just another one about the politics of MySQL now, Oracle, and so on. I mean, is forking kind of where MySQL is headed and keeping open source, or is Oracle really being a good patron to?
Well, yeah, I think it's like always hard to answer this question. Like, I think the honest answer would be, right, is what, so we don't really know.